Hi all, this presentation is part of our course project of the course Information Retrieval and Extraction at IIIT Hyderabad. Our topic is automatic text scoring and our team members are Akhilesh, Sagar, myself Saiteja and Suma. An automatic text scoring system is a system which looks at an essay and tries to assign a score depending on the various features of the essay. Typically, these features would be the essay length, the correctness of grammar, the various semantic and syntactic features of the essay. Handcrafting these features requires a lot of human involvement in order to train a machine learning model. So, basically, the aim is for the machine learning model to learn these features itself. The state of the art model is the Skipflow LSTM model, which generates neural coherence features and observes semantic relatedness over time, and thus beating all the previous machine learning models. Such a system has widespread benefits to the education industry, especially while scoring the essays without any human intervention. This also improves the feedback cycle in high stake assessments like essay scoring of exams like GRE and TOEFL. In order to train our Skipflow LSTM model, we use the Automated Student Assessment Prize ASAP dataset from Kaggle, where we are provided access to hand score essays of 8 different types. In the above table, you can see the different categories of essays, the number of essays, and the average length, along with the ranges of scores of those essays. Let us have a look at the architecture of the Skipflow LSTM model. At the start, we give the words of the essay as an input to an embedding layer, whose outputs are now fed into an LSTM layer. At this point, we have outputs at every time step from the LSTM layer. We now utilize the temporal mean pooling layer in order to pool all these features at every time step of the LSTM. This temporal mean pooling layer gives us an embedded representation of the final essay. We now implement the neural tensor layer, which takes in a tuple of LSTM outputs separated by a relevance width delta and outputs a neural coherence feature which measures the coherence of these two outputs. So basically, this gives us the similarity of how the essay concepts are holding over this width of delta. Concatenating these neural coherence features and the mean pooling feature, we give these concatenated features to the hidden layer and then followed by a linear layer and sigmoid function, which gives us the final essay score. The experimental setup involved 5-fold cross-validation to evaluate systems with a 60-20-20 split for train validation and test sets. The metric used was the quadratic weighted kappa score, which measures the agreement between the score given by the raters and the score which is predicted from our Skipflow LSTM model. Above are the observed kappa scores from our Skipflow LSTM model. The average score for the state of the art model is 76. We finished the implementation of the complete end-to-end system and compared the metrics which we obtained with that of the original paper. Let us now have a look at the interactive demo which we built. Enter the essay in the text box, select the category, and then when we click on submit, we get the predicted output. Let's try another example with this sentence, which is category 4, and now we click on submit. The predicted output is 0. Thus, given a particular category of an essay, we are loading that corresponding model and then predicting the given essay score.